Hi guys, this is Edureka from Edureka. I welcome you to today's session on Rust tutorial. Now Rust is a recently developed system programming language that is growing at a very steady pace. So without any further ado, let's get started and we'll look at the topics that we'll be covering in today's session. So first of all, we're going to see why we should learn Rust, why it is important, and then we'll move on to what is Rust. We're going to discuss a few key features of Rust, and then we'll see Rust fundamentals, where we'll see how to install Rust on our systems. We'll also discuss the basic concepts of Rust like variables, constants. We'll see data types. We'll also see conditional statements. We'll see loops. We'll discuss ownership, modules, and a few other concepts of Rust. And also I'll be executing small code snippets of Rust so that you all can understand this in a better way. So guys, without any further ado, let's move on to our first topic. Now, why should we learn Rust? Now, the first feature of Rust is concurrency. Now, handling concurrent programming safely and efficiently is one of Rust's major goals. Concurrent programming is when different parts of a program execute independently. Now, guys, initially the Rust team thought that ensuring memory safety and preventing concurrency problems were two separate challenges. But later on, the team discovered that the ownership is a powerful tool to help and manage memory safety and concurrency problems at once. So what they did was, by leveraging ownership and type checking, many concurrency errors are actually compile time errors in Rust rather than runtime errors. So if your code is incorrect, Rust will refuse to compile it and it will present an error explaining the program. So then you can fix your code while you're working on it rather than after it has been shipped to production. Okay. Now the next reason why Rust is so famous is because of its memory safety. Now the biggest and most vital difference between Rust and C++ is the emphasis on writing safe code. So with safe code, objects are managed by the programming language from the beginning to end. So for example, for a given object, the proper amount of memory is promised to be allocated. It is impossible to accidentally access a memory location that is out of bounds. And once you're done using the object, it will automatically be deallocated by the system. Okay. Now the next feature of Rust is zero cost abstraction. Now zero cost abstraction basically means paying no penalty for the abstraction and only paying for the features you actually use. So in Rust, we add abstractions without affecting the runtime performance of the code. Now this improves the code quality and readability of the code without any runtime performance cost. Okay. So next we have Cargo Package Manager. So a key characteristic of most modern programming languages is a strong package management tool. So we know that Ruby has gems and bundler, Python has pip, and similarly Rust has the infamous Cargo Package Manager. Now system languages like C and C++ have never really had any standard package management tools. Now a language with a packaging system has some advantages over the ones that don't. For starters, most of these languages have large volumes of open source libraries and frameworks. Now, these libraries and frameworks not only allow developers to create faster code by reusing the work of others, but it also makes it far easier to distribute code to end users. Okay, so moving on, according to the 2018 Stack Overflow Developer Survey, Rust is the most loved programming language for the third year in a row, and it is one of the top 10 most wanted languages. Now, not only does it provide a unique combination of performance and security, it also empowers developers with the tools to start shipping their code faster. Now, let's discuss what is Rust and we look at a few key features of Rust. Now, Rust is a new systems programming language released by Mozilla that runs blazingly fast, guarantees memory safety, and ensures effective programming. Now, let's discuss a few key features. Now, the first one is zero cost abstraction. Now, like I mentioned earlier, in Rust, we can add abstractions without affecting runtime performance of the code. So it basically improves the code quality and the readability of the code without any runtime performance cost. Next feature is that it ensures memory safety. So let me tell you that Rust guarantees the memory safety by using the concept of ownership. So ownership is a middle ground between the memory control of C and the garbage collection of Java. So basically in Rust programs, memory space is owned by the variables and temporarily borrowed by other variables. So this allows Rust to provide memory safety at the compile time without relying on the garbage collector. Now the next feature is error messages. Now Rust is very good in case of clarity. Error messages are displayed with formatting, colors, and also suggest misspelling in our programs. Now, the next feature is efficiency binding. Rust provides the feature of efficiency binding, which means that Rust language can interoperate with the C language. So basically, Rust provides a foreign function interface to communicate with C APIs and leverage its ownership systems to guarantee the memory safety at the same time. Okay. Rust also provides the feature of pattern matching. So basically, patterns in Rust are used in conjunction with the match expressions to give more control over the program's control flow. And lastly, it provides threads without any data races. Now, a data race is a condition when two or more threads are accessing the same memory location. So basically, Rust provides a feature of threads without data races because of the ownership system. Ownership system transmits only the owners of different objects to different threads, and two threads can never own the same variable with write access. So this avoids data races. Okay. So now that you have a basic idea of what Rust is, let's install Rust in our systems. So the first step would be to download Rust through RustUp. Now RustUp is basically a command line tool for managing Rust versions and the associated tools. So guys, if you're using Linux or Mac OS, open a terminal and enter this command. So I'm going to open up my terminal now. So I've just copy pasted this command from the official documentation. I'll leave a link in the description, or y'all can copy it down simultaneously. Okay. So basically what this command does is it downloads a script and it starts the installation of the RustUp tool. So this RustUp tool will install the latest stable version of Rust in your system. Okay. So guys, just bear with me until the download is complete. All right. So guys, if Rust is successfully installed in your system, you're going to get a message like this. Just wait a second, I'll clear my terminal. Okay. So type this command to check if you have the correct version or if it's been installed correctly. So this returns the version of Rust. So now that you've installed Rust on your system, let's run a simple hello world program. Okay, so for practice purpose, we're going to open up a new directory and let's name this Rust. So you guys can name it whatever you like. So I'm going to move into the directory now. All right. So I'm going to make another directory in this and I'm going to name it hello world or just hello. So I'm going to use a gedit editor. So now what I'm doing is I'm going to make a new source file and I'm going to call it main.rs. So Rust files always end with the .rs extension. And if you're using more than one word in your file name, then you can use an underscore to separate them. Okay. So I'm just going to name my file as main.rs for now. All right. So let me just type out the code and then I'll explain what happens over here. All right. Now just save the file and go back to your terminal window. So guys, don't worry, I'm going to get back to the code and explain what happened there. First, let's just compile and run the file. Okay, so if you're on Linux or Mac, then you can enter the following commands to compile it and run the file. So to compile it, we're going to run this command. All right, so it's rustc, paste the name of your file with the extension .rs. Okay, so you can see that it's finished compiling. Now, in order to run it, you're going to type / name of the file. Okay, so here you can see that it's printed hello world on the screen. Okay, now let's go back into the file and see what happened here. Okay, now this first line over here, fn main, this line basically defines a function in Rust. Now the main function is a special kind of function. So basically anything that is enclosed within the main function will get executed first. Okay, now the first line basically declares a function called main by using the keyword fn. Okay, now there are no parameters to these functions, but if you wanted to add parameters, then you'd enter it over here within parentheses. Okay, so this was the first line of code. Now inside this main function, you can see this line, println hello world. Okay, now this line does all the work in the program. It basically prints this text, which is hello world, onto the screen. Okay, Now, basically, this println with an exclamatory mark is a Rust macro. Now, guys, this is not actually a function, it is a macro. So if you wanted to call a function, you would remove the exclamatory mark. All right. Now, we use macro in this case. And then next, we've just passed this hello world string as an argument to this println macro. All right. And not to forget that you have to terminate this with a semicolon. Okay. So guys, that's it. I hope you all understood this hello world program. It's very simple. Here you're just defining a main function, and whatever is typed within the main function always gets executed first. Okay. And this println with an exclamatory mark is basically a macro. And within this macro, we are passing a string which says hello world, and we're also terminating it with a semicolon. So guys, I hope you all are clear with these basics. It's very important to understand basics properly because that's how you learn the most advanced concepts. Now, next, what we're going to do is we're going to create the same Hello World program, but we're going to use Cargo over here. Now, earlier I spoke about Cargo, which is basically a package management tool for Rust. So, like I discussed earlier, Cargo is Rust build system and package manager. Now, why we use Cargo is because it handles a lot of tasks for you, such as it builds your code, it downloads the libraries that your code depends on, and it also builds those libraries. Okay. Now, obviously, the Hello World program doesn't have any dependencies, but if you write any complex program which has a lot of dependencies, then Cargo is going to manage all those dependencies and download all those dependencies for you. Okay. So the first thing we're going to do is we're going to check if Cargo is installed. Now, usually Cargo comes installed with Rust. So in order to check if Cargo is installed, you're just going to enter this command. Let's enter this cargo -- version. Okay. So basically this returns the version of Cargo. So guys, if you followed the installation that I showed you, then you'll definitely have Cargo installed. All right. So let's get started with Cargo over here. I'm going to move back to my Rust directory first. Now, in order to create a new project or a new directory in Cargo, you're going to use this Cargo new and name of the directory. So I'm just going to name it hello. All right, sorry, hello is already taken. So I'll name it hello-cargo. Okay. Now what I'm going to do is I'm going to move into the directory. Okay. Now when you do ls over here and you list the items, you see a cargo.toml file. Now this file is basically stands for Tom's obvious minimal language. Now this file is basically used for configuration purposes. Now let's open up this file and see what it has. All right. Now this package basically indicates that any statements under this package are just configuring a package. Okay. Now these three lines are basically configuration information that Cargo needs to compile your program. Okay. So basically here there is name, version and author. Now these are just configuration information. And if you want to change the author, you can go ahead and change it over here. And because this program has no dependencies, so this is just left blank. Obviously, it's a Hello World program, so we do not expect to have any dependencies on this. Okay. So usually if you have a complex program, you're going to list down your dependencies over here. Okay. Now let's come out of this file and we'll move into the src directory. Now this is basically the source directory. What you're going to do is you're going to open up a file over here. I'm going to name it main.rs as usual. So .rs is the Rust extension like I mentioned earlier. Okay. So when you open this, you'll see that this function has been generated for you automatically. So basically Cargo generated this hello world program just like the one you wrote earlier. Okay. So now what we're going to do is let's build this project. Since this project is already there for you, let's just build this project and run it. Now, in order to build the project, you're going to run this command, cargo build. Okay, so it says compiling and it's finished compiling. Now let's just run the program. So it's a simple command which says cargo run. And here you can see the output which is hello world. Okay, so guys, obviously here you did not see a lot of functionalities of Cargo because it was a simple program of running hello world. And when you have complex programs, like I mentioned earlier, you're going to have a lot of dependencies. So Cargo is going to be very useful in such cases. Okay. So guys, now that you've installed Rust on your system, you've run a Hello World program on Rust as well as you've used Cargo to run the program. Let's look at a few Rust fundamentals. I'm sure all of you have come across these fundamentals. We have basic concepts like variables and all. So anybody who's familiar with other programming languages like C, C++ are going to find these very easy. Okay. So now let's look at our first topic. So what is a variable? Now variable is basically a name that you give to a memory location where you can store some value. So basically, let's say that I have a variable called age. Okay. So the name of this variable is age. Now in this variable, I'm going to store a value, let's say 15. So basically this is what variables do. They are basically memory locations where you can store some value. Now, basically in Rust, by default, variables are immutable. Now, when I say immutable, it means that once a value is bound to a variable name, you won't be able to change that value. Okay, so it's going to remain fixed. So by default, variables are immutable in Rust, but you have the option to change this. Okay, by just using this keyword mut, you can make your variable mutable, meaning that you can change the value of the variable. So guys, if this is confusing, let me just execute a small program so that y'all can understand it better. Okay, so I'm just going to move out of these two directories. I'll clear out the screen for y'all. Okay, so first what I'm going to do is I'm going to use cargo. So I'm going to create a new directory using cargo. So we saw earlier that in order to make a new directory using cargo, you're going to use this command, cargo new space name of the directory. So I'm going to name it variables. Okay. Now let's move into the directory. Let's move into the src directory, and now I'm going to open a file called main.rs. Okay, so by default this is going to have the hello world program in it. So what you're going to do is let's just erase this code. So what I'm doing here is I'm declaring a variable called y and I'm setting its value to 15. Now let's just print the value of the variable. So we know that in order to print, we're going to use a macro print ln. So within this, we're going to pass an argument, whatever we want to print. So I'm just going to print the value of y, right, and pass y. Sorry, this is a comma and pass y over here. Okay, now let's run this and see how this works. So save your file, and so here you saw that I didn't actually build the program first. I just ran it directly, but Rust automatically compiled it even though I didn't build my project. Okay. So here you can see that it displayed the value of y as 15, which is correct. Now let's make a small modification to this code. Okay. What I'm going to do here is I'm going to reinitialize the value of y. I'm going to make it 16. Now let's print the value and see what happens. Okay. I'm just going to copy paste this line. I'm sorry guys, I'm quite lazy. So let's paste it. Now save the file and let's check the output. Okay, cargo run. Here you can see that it's given me an error message, and the error message says that it cannot assign twice to immutable variable y. Okay, so guys, what I did here was, let's go back to the code. What I've done here is I declared a variable y and I set its value to 15. Now, like I said earlier, that by default, the variables in Rust are immutable, meaning that they cannot be changed. So once you fix the value of a variable, you cannot reinitialize the value of that variable. Okay. But if you want to do this, then you can just use this keyword after let, which is mut. Okay. So if you add this keyword after let, after this keyword, then definitely you can change the value of y. Okay. Now let's save this program and let's see if this executes. All right. So here you can see that it's printed the value of y is 15 first, and then the value of y is 16. Okay. So guys, I forgot to mention one important thing. Going back to the file. Now over here, what we did was we used the let keyword to declare a variable. So guys, in Rust, you always use the let keyword. Okay. So the let keyword is used to declare a variable. But if you want to make the variable mutable, then you're going to use mut, which stands for mutability. Okay. So you're going to just use these two keywords. And what you're going to do is after let, you're just going to write the name of the variable and then you can assign the value to the variable. So if you want to initialize it here, you can do it. Or you can also just set the value and leave it. This is also called declaring a variable. So what you're doing here is you're just declaring the variable, but you're not initializing its value. Okay. So guys, I hope you all are clear with variables, and I hope you're all clear with the mutability and immutability concept. So in order to make a variable mutable, all you have to do is you have to add the mut keyword after declaring the variable. Okay. Alright guys, I hope variables are clear to you. Now let's move on to constants. So we all know that constants are basically fixed values that will not change during execution time. So once you've set the value of a constant variable, you won't be able to change it. So basically constants are variables that do not change values, and that's why they're called constants. Okay. Constants aren't just immutable by default, but they are always immutable. Now, in order to declare a constant variable, you're going to use a const keyword instead of a let keyword. So let's look at how this is done. I'm going to go back to the terminal. I'll make a new directory called constant. Okay, here you can see that I'm using cargo new. Remember that this is how you make a directory using cargo. Now I'll just move to the directory. Okay, now I'll move into the source directory and I'll open a file called main.rs. So I'll just replace this code with a small line. All right. Now what I'm going to do is I'm going to declare a constant variable. Now in order to declare a constant variable, you use the keyword const. All right. Now let's name the variable x. All right. And I'm going to set it to some value. Okay. And let's just print out this value. All right. Save the changes and go to your terminal and perform cargo run. Okay. All right. So here the error says that it's expecting a colon over here. Now I'll tell you what this error actually is. So what I've done here is I've defined a constant, but I've not defined what kind of data type this constant is. Okay. In order to define data types in Rust, you're going to use this syntax. Okay. So you're going to put a semicolon after the name of the variable or after the name of the constant, and you're going to write the data type. Okay, so what I did here was I declared a floating point variable. F stands for floating point, and it is of 32-bit. So this is how data types are defined. So basically, I'm using the constant keyword to define a constant variable. And after defining the name of the variable, I'm going to use a colon and I'm going to define the data type of this variable. Okay. And then I'm initializing the variable to a specific value. Okay. Now let's save the file and see if this works. All right, I'll just clear up the terminal first and let's perform cargo run. All right, so this gave me a warning over here. It says that constant x should have an uppercase name such as this. I forgot to mention a point about constants. You always declare them in capital letters. So it has to be something like this. So the name of a constant is always in capitals. Okay, save the file and let's hope that we don't get that warning again. Okay, let's perform cargo run. All right, so I forgot to change X over here. So guys, this shows that Rust is actually case sensitive. So guys, you need to be careful about case sensitivity. So going back into my file, I'll just make this capital X. All right, now saving the changes. This should definitely work. Okay, let me just clear up the terminal and let's run. Okay, so this has given us a good output. It says the value of X is 1.54. Okay. All right. So guys, with this, we are done with constants. Now let's look at our next topic. Okay. So our next topic is data types. Now basically every value in Rust is of a certain data type. Okay. And there are two categories of data types in Rust. One is scalar and the other is compound data types. Now a scalar type represents a single value, and under scalar data types, we have four types. The first is integers, floating point, boolean, and character. Now let's declare each of these and see how they work. So I'm going back to my terminal. Let me come out of these two directories first. Okay, so the first step obviously is that I'm going to make a new directory using cargo. I'll name it data types. Now I'll change the directory. I'll move into the src directory and let's open up a file. I'm going to call it main.rs. So we need to replace this entire code. So first what we're going to see is integers. So I'm just going to write it down for y'all here so that y'all can understand better. Now I'm going to define a variable called z. Now we're going to look at the data types. So I'm going to write u32 is equal to 4. I'll tell you what this means. So what I did here is I declared a variable called z, and here I'm just trying to define the data type of this variable. Now u32 basically indicates that z is an unsigned integer which takes up 32 bits of space. Now you can also have signed integers. So in order to declare a signed integer, you would do something like this. Or let's say that this integer takes up 64-bit space. So you can have 64-bit space as well. So basically, I would represent a signed integer. Now let's look at our next data type. Next would be floating point. Alright. So what I did here was I declared a variable called x and I set its value to 2.1. Now by default, this is of F64 type. Now F64 basically stands for a floating point variable which takes up 64 bits of space. By default, x would take up F64. But if you want to specify how many bits you want to give to this variable, then just let's say I want it to take up 32 bit space. So this is what I would do. So that was floating point. Now let's look at Boolean. So if I declare a variable like this would be considered Boolean. So again over here, if you do not specify the type, it's going to consider this as Boolean because Boolean only has two values to it. It has true or false. So if you want to specify the type, then you're going to do something like this. And you're going to set the value to false or true, whichever you like. So here I specified that it is a Boolean type. You can see BOOL, which stands for Boolean. Now let's look at the next type, which is a character. So over here, what I did was I created a variable called a by using the let keyword, of course, and then I set its value to Edureka. So what is different here is that I'm enclosing the value of this variable within double quotation marks. So by doing this, the system knows that this is a character. Now let's just print the value of this and see if it works. Let's say hello from Edureka. So we'll just pass a over here. Okay, I'm just going to save this and I'm just going to comment these things because it might cause an error. So I'm going to save this up again and let's see if this runs. So how do you run a program? You use cargo run, or you can also build it and then run it. Okay, so this compiles successfully. It prints hello from Edureka. Okay, so guys, I hope with that you're clear with scalar data types. Now let's move on to our next topic, which is compound data types. Now under compound data types, we first have arrays. So what are arrays? So array is basically a data structure that contains a list of elements. Now these elements are all of the same data type. Okay. Now arrays in Rust are very different from arrays in other languages because arrays in Rust have a fixed length. You can't add or remove items from an array list. Okay. So now let's see how you declare an array. Let's go back to our terminal. I'm going to clear the screen for you and also exit from these directories. Okay, so I'm going to start again with creating a new directory over here. I'll name it arrays and let's change our directory to, arrays. Okay, now I'll move to the source directory and I'm going to open up a file called main.rs. Okay guys, so don't worry, you'll get used to this technique. Okay, now what we're going to do is we'll replace this code. This might seem meaningless or tedious for y'all because we're not actually using up a lot in cargo. Cargo does not have any functionality over here because I'm just making you understand the basic concepts of Rust. But when it came to huge complex projects, which we'll soon learn, for those having cargo is very important because we always face a lot of dependencies issues. So if you shift from the testing environment to your production environment, there can be a lot of dependencies issues. So basically cargo helps you get rid of those dependencies issues. So let me just type out a few lines of code. Okay, so I'll type this out and then I'll explain what I'm actually doing over here. All right. Now, before I type the further code, let me just explain what this line is doing over here. So first is the let keyword. So you're using the let keyword to declare an array because arrays are basically variables which can store many values. So just like how you define a variable or declare a variable, we're going to use the let keyword here as well. Okay. Now first you use a square bracket over here. You can see the square bracket. So square brackets are basically the syntax of creating an array. I'm sure all of you who are familiar with other programming languages know that a square bracket is necessary for arrays. Now inside this first square bracket, you can see that there are two pieces of information. Now before that, let me tell you that the name of the array is obviously A, and I put a colon over here and I've enclosed two pieces of information in this. Okay. Now the first is the type of each element in this array. So every element in this array, 1, 2, 3, 4, and 5, are of the type I32, which is a signed 32-bit integer. So each of these arrays have to be of the same type, because in a single array you cannot have different data types. Each value has to be of the same data type. Now the next parameter over here, which is 5, this basically stands for the length of the array. So how many ever elements you're entering in this array is defined over here. So I'm entering 5 elements in the array, so the length of my array is 5. Okay, so I hope all of you are clear with this part. Now let's just play with this a little bit. I'm going to define an array index. Okay, and then let's just declare an element and we can store the index over here. Now let me just print something on the screen. So here I've just set the index to 3 and I'm basically creating a variable called element wherein I'm going to store a of 3 because index has a value 3. So a of 3 is going to be printed on the screen and a of 3 basically is this value. Arrays always begin with 0. So this is 0, this is a of 1, this is a of 2, this is a of 3 and this is a of 4. Okay. Now let's just save this program and let's run the program. So it printed the value of the element is 4. So guys, I hope all of you are clear with arrays. Alright, so the next thing we're going to talk about is tuples. Okay, so now a tuple is a data structure that contains a list of elements. Now these elements can be of different data types, like they can be integers, they can be strings, and they can be a mix of different values. Now, one important point about tuples is that tuples have a fixed length. Okay, so once you declare them, they cannot grow or they cannot shrink in size. So this way they're similar to arrays. They have a fixed length. Now, this is an example of a tuple. What we're going to do is we're going to open up our terminal and to better understand it, we'll execute it over here. So I'm going to start with creating a new directory using cargo new. I'll call it tuples. Okay, so I'm just going to open up a file. So guys, just bear with me. I'll type out the code and then I'll explain what is happening over here. So basically, I started off by using the let keyword and I declared a tuple called tup. Okay, tup basically. Within this brackets, you can see 3 values over here. Since tuple is basically a list of values, you're just going to type these values within parentheses separated by commas. Okay. So how do we create a tuple? So we create a tuple by writing a comma separated list of values inside of parentheses. 500 is an integer, this is a floating point, this is again an integer. Okay, so we have different type of values over here. So you know that tuples support different data types. So we're just assigning xyz variables to these values and we're just printing out the value of y. Okay, so I hope you all are clear with this. Let's save the file and let's try to run the program. So we're going to use cargo run. Alright, now these warnings can be ignored because it says unused variable z and unused variable x. Now, apart from that, this successfully printed the value of y. So like I mentioned, tuples have a fixed length. You cannot change the length of a tuple, but they can store different data types. Okay, they can have values of different data types in them. Now, moving on, we have strings. Okay, so guys, I forgot to mention to y'all that I didn't actually specify the data type of each of these values. Okay, but you can assign data types. By default, Rust knows that this is an integer and this is a floating point and this is again an integer. Okay, but if you want, you can specify the data types. If you want to store a 32-bit variable or if you want to store a 64-bit variable. So you can do that. And now let's move on to our next topic. So we have strings. Now a string is basically an array of characters. So basically a list of characters would be a string. Now let's just get on directly with declaring a string. So I'm going to open up my terminal. Let me come out of these two directories and I'll clear the screen for you. Also, I'm going to build a new directory using cargo new and I'll name it strings. Okay, so I'm just going to type out the code first. So I'm going to use the let keyword and I'm also going to make it mutable. So I'm going to use mut and then the name of the string is s. After that, all right. So I'm sure all of you understood the left side of this, which is let mute s, which is basically I've declared a string with the let keyword and then I've used mut keyword, which makes the string mutable. Okay, so which means that you can change the value of the string at any point of time. Now what this line does is it basically creates a new empty string called s. Okay, so that's why you're using this function. It's basically creating a new empty string called s. Now you can load any value into this s and you can print it out. Okay, let's say that I have some data. I'm going to name the variable data. I'm going to store some, let's say we'll say hello from Edureka. So it has some message in this variable and what I can do is I can pass this message to the string like this. So what I did here was I'm just passing this value which I stored in a variable called data to this string that I had defined earlier, which is s. Okay, so this was an empty string. Now I'm just storing some value in this string. Now let's save the program and let's try to run the program. Alright, so I misspelled println over here. Going back to the function. So guys, remember again, this keeps reminding me that Rust is actually case sensitive. So make sure that you do not make mistakes like these. Okay, now let's try and run the program. So we're getting warnings which are okay. You don't have to worry about warnings. It just says unused variable and the variable does not need to be mutable. That's okay because we're not actually changing the value of the variable. So they are just giving us a warning saying that, you don't have to mute a variable if you're not actually changing the value. Okay, so now this printed out hello from Edureka, which is correct. That's exactly what I wanted. So guys, with this, I hope you all are clear with strings and how you create new strings. Okay. Now let's move on to our next topic. So next we have functions. Now what are functions? Now functions are basic building blocks of a program and each function performs some specific task. Now let's look at an example of a function. So we'll just see an example of a function which calculates the product of two numbers. So we're going to start off with creating a new directory. Okay, I'm going to name it funct and then I'll change the directory to function and again I'll move into the source directory and I'll open up a file. So let me just type out the code and then I'll explain what the code actually does. Alright, so what I did here was let's discuss this function first. So what I did was I created a function called prod and I used the fn keyword to do this. Okay, so we know that from beginning we've been using the main function and that was declared using the fn keyword. Okay, so that's what I did here. I created a function called prod. Now this function has a few parameters. Now these parameters are enclosed within these parentheses. Now, for each of these parameters, I've also defined their data types. So X is one variable and it is of the type integer and it can store a value of 32 bits. Okay. Similarly, I've declared a variable Y with I32 as well. Now within this function, I'm just going to, sorry, I've written sum over here. It is product. Now what I'm going to do is I'm going to use this macro to print the product of these two values. Now in the main function, what I'm doing here is I'm just calling this prod function with this set of arguments. Now when you define parameters, you're just defining the variables. You're not actually setting any values to x and y. Okay, here we've just defined the variables, we've just declared them, but we haven't set any value. In order to set the value, you call that function, and within the function you define arguments. Okay, these arguments are values to these variables x and y. Okay, now let's save the function. Now this should give us an answer of 9 into 3, which is 27. Okay, let's run the program and let's see whether it works. Alright, so over here you can see that we've got the product as 27. So this proves that this function actually worked. So guys, I hope all of you are clear with functions. Now let's move on to conditional statements. So we're going to discuss if statement, we're going to discuss else and else if. Okay. Now condition statements are basically used to perform different actions based on different conditions. Okay. Now let's discuss the if statement first. Now if is used to execute a block of code only if the condition is true. So look at the syntax. So as long as this condition holds true, the statement within the if loop will get executed. The statement or the set of statements will get executed. Alright, now let's discuss else, and let's also discuss else if. So now let's look at else. Now else is used to execute a block of code if the same condition holds false. Now we know that if the condition holds true, then a statement A will get executed. But if the condition holds false and you want to execute an alternative statement, that's when you use else. Now if this condition holds false, then this statement will get executed. Now then you have else if. So what happens with else if is that you can have multiple conditions by combining if, else if, and else. So let's just execute a block of code. You'll understand this in a better way. So I'm going to open up my terminal. Okay, so again, I'm going to start off with creating a new directory. I'll call it if. Okay, I cannot use if because it is a keyword. So the name of my directory is going to be conditional. I'll change to conditional. Okay, and now I'll move into the source directory and I'll open up a file. I'm gonna declare a mutable variable called n. I'll store a value of, let's say, 3. All right. Now I'll use the if block over here. So if n is less than 0, it'll perform the following statement, which is it'll basically print. So what I've done here is I've defined a condition n less than 0. So if n is less than 0, then this statement will get executed. Now let's define an else if and else block also over here. So in the else block, I'm going to say, now for this else if, I'm going to define a condition, which I'm going to say n greater than 0. Now if this condition n greater than 0 holds true, then whatever I type out over here will get executed. Next, I'm going to define else. Now I'll just explain this once more to y'all. So I've defined a mutable variable and I've set the value of that variable to 3. So basically the first condition, if n is less than 0. So if n is less than 0, it's going to print n is a negative number. So basically 3 is negative, which is not true. So that's why it's going to go to the next condition, which is else if n is greater than 0. Now if n is greater than 0, which holds true because 3 is greater than 0, then this is going to get printed. Okay. Now if neither of these are true, it's going to print this, which is 3 is 0, which is not true. Okay, now let's just save this, and we should technically get a 3 is positive as the answer. So let's run this and see what happens. Okay, you saw 3 is positive. Okay, that was your final answer. So don't worry about this error. It says that we've not used the mutable variable. Now what I'm going to do is I'm going to change the value of this to 0. So by doing this, technically this statement has to get printed. Let's see if it works. Yeah, it says 0, 0. Basically, the value of that is 0. So guys, I hope you all are clear with conditional statements. Now let's move on to our next topic, which is loop. Now a loop is basically used when you want to execute a block of code repeatedly until some condition is met. So let's just look at an example. We'll see how this works. So what I'm going to do is I'm going to create a new directory. I'll call it loops. And on it. Now what I'm going to do here is I'm going to type out a code. So what I'm doing first is I'm declaring a loop. So you use the loop keyword to declare a loop. Okay. And then I'm going to declare a mutable variable called I. I'll set its value to 0. And then I'm going to have a simple println macro. Okay. In this, I'm going to say the number is, and also I'm going to increment the value of I. So basically this is going to give me an infinite loop, but I'll just explain what this does. So what I've done here is I've defined a mutable variable called I and I've set it to 0. I've initialized it to 0 and then I'm declaring a loop within which I have a simple print state. So basically it's going to print the number is 0. It's going to print the value of I, which is 0, and then it's going to increment the value of I. So I over here is going to become 1 because you're going to do 0 plus 1, which is 1. Alright, then it'll go back to the loop and it'll keep printing. It'll print the number is 1, and similarly the number is 2. It'll keep incrementing, and this is just going to be an infinite loop. Let's see if it works. Okay, so I'm just going to press Ctrl C and I'm going to stop the execution. But here you can see that it's basically been incrementing values from 0 it started, and it's been incrementing values. Okay, so this is how a loop works. It repetitively executes a set of code with different values. Okay, so I've given it different values. First it starts off with 0 and then I keep incrementing the value of I. So I've set it to 1, then 2, then 3. It keeps adding 1 every time. So every time the loop gets executed, 1 is added. So this was about loop. Alright, so the next loop we have is the for loop. Now what this for loop does is it repeatedly executes a loop code as long as a given condition holds true. So it tests the condition before it executes a loop body. So this is the syntax for a for loop in Rust. This is a little bit different from what you see in C++, Java, and C. So let's execute an example and let's try and understand this better. So I'm going to start off by creating a new directory. Okay, I named it for loop, and let's move into the source directory and I'm going to open up the main.rs file. So I'm just going to type out the code first. So what I'm doing over here is I'm creating an array and I'm just filling some random elements into the array. Let's say, okay, so I've just entered numbers randomly into the array. Now look at the syntax of for over here. So over here you can see on the syntax that I have written var over here. Var basically stands for a variable. So you can declare the name of the variable over here. This is exactly what I'm doing over here. I'm just naming the variable as I. Okay. And I in a dot iter. Now this iter is basically a iterating function. Now this function is basically going to iterate through this array. Okay, so it's going to iterate through the array A. Now this is the array A. So basically this A dot iter is going to iterate through this array. So one by one it's going to start iterating. So first it's going to go to the 0th element, 1, 2, 3, 4. Similarly it's going to go on. Okay, so this is A of 0, A of 1, A of 2. So it's just going to keep iterating through the array. Okay, now I'm just going to have a println macro. Okay, here I'm going to say the value is, I'm going to close the for loop and let's save this code and let's run it and see if it works. Now before I do that, let me just explain this to you again. So what I did in the first line over here is I created an array of elements, okay, and the name of the array is A. Then I'm opening a for loop, and within the for loop I'm just going to iterate through the array, okay. And as I iterate through the array, I'm just going to print the value of each of the elements in the array, okay. So I'm going to print the value of 10, 20, 30 and so on. So now let's close this file. and let's perform cargo run. Okay, so here you can see that it's iterated through the entire array. So it starts with 10, the value is 20, 30, 40, 50, 60, and so on. Okay, so guys, with this we are done with for loops. I hope all of you are clear with for loops. Now let's move on to our next topic, which is while loop. Now this loop basically loops through the code as long as the specified condition holds true. Now let's look at an example. Alright, so we're going to start off with creating a new directory using cargo new. I'm going to name it whiles. Okay, now let's change the directory. I'm going to move into the source directory and open a file. Now what I'm going to do here is I'll type out a simple code. So first I'm going to declare a mutable variable called I, and I'm going to initialize it to 0. Then I'm going to set a while condition which says while I is less than 5, it'll perform the following. So while I is less than 5, it's going to print this on the screen. So guys, we already looked at this example earlier, but this time we're going to see how you use while to do this. Okay. Now again, I'm going to increment the value of I. So what I'm doing over here is I have declared a mutable variable called I, and I've initialized its value to 0. Then I'm setting a condition which says I less than 5. So while I is less than 5, these two lines are going to get executed. So first what's going to happen is it's going to execute the number is 0 because we have initialized the value of I to 0. So it's going to print the number is 0, and then it's going to come here and increment the value of I. So the next time it goes to the while loop, the value of I will be 1. Now 1 is less than 5, which holds true. So it's going to print this. Similarly, it's going to keep going as long as the value of I is less than 5. Okay, let's save this and let's open our terminal and let's run this file. So here you can see that it has printed only up to the number is 4 because we had set a condition which says I is less than 5. So guys, I hope all of you are clear with the while loop. Now let's move on to our next topic, which is ownership. Alright, so now let me explain what ownership really is. So basically every program has to manage the way it uses the computer's memory while it's executing. Okay. Now some languages have the garbage collection method which constantly looks for no longer use memory. Then apart from that, there are other languages where the programmer must explicitly allocate and free the memory. But when it comes to Rust, it uses a third approach wherein memory is managed through a system of ownership with a set of rules that the compiler checks at compile time. So let me tell you that the ownership feature does not slow down your computer while it's running. So there's absolutely no drawback to ownership. In fact, it's very beneficial. It solves a lot of compile time errors and runtime errors. Now, there are certain set of rules that you need to follow when it comes to ownership. So every value has a variable associated, which is the owner. So what I'm doing over here is I'm creating a variable called x who's storing a value 12. So basically x is the owner of this value. Now the next rule is that there can only be one owner at a time. Okay, now when I do let x is equal to 12, it means that only x can own this value. There's no other variable that can own this value because at present I've assigned x to 12. And the third rule is that if the owner goes out of scope, then the value associated with it is destroyed. So if this owner goes out of scope, then the value associated with it will be destroyed. So here what I've done is in this example, I have created a variable called x. Alright, x bounds to the value 12. Now in the second line, what I'm doing is the value of x is assigned to the variable y. So usually what you think is that a copy of x is being created and it's being moved to y. So let's look at this example over here. Now what I've done is I have bound this variable x to value 12. Okay, so x basically is the owner of 12. But in the second line of code, I'm assigning the value of x to y. So here what happens is the value of x is basically moved to y. Okay, so basically the ownership of x is getting transferred to y. And the variable x gets destroyed. Okay, so if we try to reuse the variable x, then Rust is going to throw us an error over here. So guys, basically this is how ownership works. So instead of actually copying the value of x to y, the entire value of x gets moved to y and x gets destroyed. Okay, so this is a very good concept. It helps to save a lot of memory and it also secures memory in this way. Okay, so we know that basically if I'm assigning a value to x, no other variable can hold that value. Okay, so x is the owner of that value. All right, guys, so I hope all of you are clear with ownership. This is a very important concept when it comes to Rust. All right, so now let's look at structures. Now, a structure is basically a user-defined data type that can have variables of different data types. Okay, so it can have integers, it can have strings, it can have characters, it can have floating point variables. So it's basically a user-defined data type that can have different values in it. Okay, now let's look at a practical example of this. All right, so I'm just going to open a new directory and I'm going to call it structures. Okay, so I'm just going to type out a few lines of code. So first what I'm doing is I am declaring a structure called rectangle, and within this structure I'm going to define two variables and I'm going to set their data types as well. So I'm defining the width and I'm defining the height. So these two are unsigned 32-bit variables, and then I'm going to close my structure. All right, now I'm going to open up. All right, so guys, I forgot to take off this main function. So I'm going to start off the program with the structure. Now I'm going to have the main function over here. Okay, so within the main function, I'm going to define another variable and I'm going to call it rect. And so let me just type this out and then I'll explain what exactly I'm doing over here. I'm going to define another function over here. All right, now I've typed out the entire code. Let me just tell you what I'm doing over here. So first I'm creating a structure by using the struct keyword and followed by the name of the structure. Okay, apart from that, I have the structure members which are enclosed in these curly braces. Okay, so width and height are basically structure members, and I have defined the data type of each of these structure members. Now, so what we're doing here in the main function is we're creating an instance of this rectangle structure that has a width of 10 and a height of 40. Okay, so we're just creating an instance of rectangle. Okay, now our area function is defined with one parameter. You can see that it's defined with one parameter, rectangle. Over here, what we've done within the area function is we've defined a single parameter called rectangle, which is of the type rectangle. Now, this rectangle refers to this structure rectangle. Now, like I mentioned earlier, that structure is basically a data type. So here in the area function, we're defining a variable called rectangle, and the data type of this variable is the structure rectangle. Okay, it's basically this. So what we're doing over here is we're going to calculate the area of the rectangle using the width and the height fields. Okay, now these width and height fields were defined in the structure itself. So guys, I hope you all are clear with this. All right. So guys, I was facing a few errors with the program, and the mistake was I put a semicolon over here. So because this is a structure, you list the structure members by listing them like this and separating them with commas. So this is my first structure element, and then I'm adding a comma and putting in my next structure element. Okay. Basically, when you compile this program, let's compile it. It should give us 400. So let's quit and let's perform cargo run. So on doing this, we get a few warnings, but that is okay. But here you can see that the area of the rectangle is 400. Okay, so we do get the output. So guys, with this, we are done with structures. I hope you all are clear with structures. So the next topic is enumerators. So an enum is basically a custom data type which contains some definite values. Okay, so it contains some definite or some constant values. So it is defined with an enum keyword. Here you can see it's defined with an enum keyword followed by the name of the enumeration. Now let's just look at a small example. Now in order to explain an enum, I'm going to type out a simple example because enumerators are usually used in complex and advanced codes. So I'm just going to briefly tell you what enumerators do. So I'll give you a simple example. So first let's create a new directory. I'm going to change the directory. Going to the source directory and I'll open a file. All right. So what I'm going to show you here is I'm just going to show you how enumerators work or how you define them, because we usually use enumerators in very advanced concepts. Let's say that I've defined an enum which stores the rainbow colors. So we know that a rainbow can't have any more extra colors in it. So that's why we're defining an enum over here. So we know that within enum you can store values which are quite definite. Okay. So first we start off with violet. You can also assign a value to violet, let's say 1. So we have indigo, and then we have blue, and then we have green, we have yellow, we have orange, and we have red. So basically we created an enum called rainbow in which we store definite set of values. We assigned a value to each of these variants. Now one thing I forgot to tell you all is within enumerators all these are called variants. So these are some definite values. Alright guys, about enumerations I'm not going to elaborate too much because we'll need a complex example. We'll need an example which has advanced Rust script written in it, which you all might not understand because this is a basic tutorial. I hope you all understood a little bit about enumerations. So over here also I've given a small example wherein you can have a program which indicates the traffic rules, wherein you have red for stop, yellow light is for ready, and go is for green. Okay, so these are definite values. All right. So now let's move on to our next topic, which is modules. Now, what is a module? It's basically a collection of items like functions and structures. Okay, now by default, the modifier of a module is always private. Okay, so a modifier of a module is something like this, mod, but you can make it public by using the public keyword, which is pub. So basically, this makes the visibility modifier as public and accessible outside the namespace. So basically, it can be accessed outside this mod, and this use is basically to import the module into local scope. Let's say that there is an existing module and you'd like to use it. So in those cases, you use this use keyword. So use and you mention the name of the module that you want to use. So if there is a standard output or input library, in those cases, you can just say use stdio and so on. Okay. So now let's look at modules a little bit in detail. All right. So I'm going to create a new directory and I'll name it mod. Okay, so a mod is a keyword, so I'm going to name in modules. Okay, I'm changing the directory and let's go into the source directory and we'll open up a file. Okay, so let's clear off this main function. So guys, bear with me while I type my program. So I'm making this public here, you can see public, and then I'm defining a function called C, and the name of the function is the same as the name of the module. So guys, in order to define a module, I'm using this keyword mod, which defines the module, and C is the name of my module. Okay, now within this function, let's just print a simple block which says C is a structured programming language. Alright, so similarly, I'm going to create another module and the name of this module will be C++. Okay, so I've just created another module called C++, within which I've created a function called C++, and I'm just printing a simple statement. Okay, now let's add the main function. So function main. Now within this, I'm just going to call the two functions, which is, so I'm basically specifying the module C along with the function C. So I'm just calling this function, okay? And the other module is C+, and the name of the function is also C+. Okay, so this is the name of the module and this is the name of the function. So basically in this program, there are two modules, which is C and C+. So what I'm doing here is I'm just calling their respective functions. That is, the module C has a public function called C, and similarly C++ has a function called C+. Okay. So guys, this is the code. I hope you all understood. Let me just go through it once more. So I'm creating a module called C over here, and then I'm creating a respective function for this module, which I've made public, and I'm just printing a line over here. Similarly, I've created another module called C+, who has a function called C+. It's a public function, and this is also printing a simple line. And then I'm calling these functions, all right, C and C++. So now let's save the changes over here and let's open up our terminal. Okay, let's run this program. So we're going to use cargo run to run the program. Okay, so here you can see that it's printed C is a structured language and C++ is an object-oriented programming language. So like I mentioned earlier, modules are basically a collection of items. So basically here I have functions. Within C module I have a function. Similarly within C+ module I have another function. Okay, so these are just collections of items. Okay, you can have arrays, you can have anything within a module. Okay, so guys, with that we are done with modules. I hope it's clear to you. So now let's move on to our next topic, which is the last topic for today, and these are called vectors. Now vector is basically a single data structure which lets you store more than one value next to each other in the memory. So there are a few key points of vectors over here, you can see. So it basically stores values of the same data type. So it is like an array which stores values of the same data type. It is denoted by this formation. And another important point is that it is a growable array. That means you can add elements to vectors. You can also remove elements from vectors. Okay, now let's look at an example in order to be more clear. So what I'm going to do is I'm going to start with creating a new directory. Let's call it vect. Okay, now let's go into the source directory and let's open a file called main. Okay, so guys, before I type out the code, let me just show you how vectors are declared. So here what I'm doing is I am using the let keyword and I'm defining a vector called v. Now let me just type this out and then I'll explain what I'm doing here. So what I've done here is I've created a vector v which is of type i32, which is a signed integer of 32-bit, and I've created this using this function which creates a new empty vector. Okay, the new function basically creates a empty vector which is of type i32 and the name of the vector is v. All right, I hope all of you are clear with the declaration over here. Another way of creating a vector would be like this. All right, so what I've done over here is I've used a macro. So whenever you see an exclamatory mark over here, it's basically a macro. Okay, so Rust provides a vector macro to create the vector and hold the values in it. Okay, so these are the values that this vector is going to store. So basically there are two ways of creating a vector and I showed you both of them. Now let's run a simple program. Okay, so let me just clear this, and now I'm creating a vector v. Just like how I showed you all, I'm going to use the vector macro in order to create a vector because I think it's simpler. So I'm just randomly going to input some values into this. So now let's print the fourth element of this vector. Now how would you do that? So what I would do is, let's say fourth element of the vector is, all right, it's v3. So what I did here was I created a vector using the vector macro and I've just added a few list of values. Now what I want to do is I want to print the fourth element. Now in order to do that, I'm just going to use this statement, and in order to access the fourth element, I'm going to use this. So we know that arrays and vectors all start from 0. So v of 0 would be 10, v of 1 would be 20, v of 2 would be 30, v of 3 would be 40. So the fourth element is basically v of 3. Okay, now let's just save this and let's see if this runs. Okay, so let's perform cargo run. Okay, so it says that fourth element of the vector is 40. Okay, so guys, this was all about vectors. With this, we come to the end of today's tutorial. So guys, I hope all of you enjoyed programming with me, and I hope all of you have a basic understanding of how Rust works. So if you have any doubts or queries related to today's session, please leave them in the comment box below and we'll try and answer all of your queries. So guys, thank you so much for watching today's session. Have a great day.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!